Good morning, everyone. I wanted to welcome you guys to the second half of this session, where we'll have a little bit of a panel discussion about the way that artificial intelligence is going to transform our future and really address some of the maybe misconceptions or hype aspects of what AI actually is. And so you just heard from Rishi just now, and I'd like to introduce myself and the rest of the panel. So my name is Sridhar Iyengar. I've been involved in sensors, IoT, machine learning for about 15 years in the healthcare industry, moving into health and wellness, consumer, and so on and so forth. And one of the things that I learned is that there's a lot of hype surrounding any new technology, whether it's wearables that I was involved in about 5-6 years ago, or whether it was digital health, or whether it's AI right now. And when you peel back all the different layers, what you realize is there's some fundamental truth that really haven't changed over years and maybe even decades. They've just been enabled by new technologies, new processing power and new mathematical models and so on and so forth. And what I find very fascinating is that when you peel back the enabling technologies, they've been around for years. However, they've been used in very new and novel ways to solve problems that may not have been around even 5-10 years ago. And I think the panel that we have today kind of exemplifies that. So without further ado, I'd like to introduce the folks on the panel. So Rishi, you've just heard recently. And next we have Sangeeta, who's the Chief Customer Officer for IASTI. And next we have Lillian, who is the Director of Product Management for the Google Assistant team. And then finally, we have Jonathan Cervelli, or Ceravelli, I think is the right pronunciation, who's the Product Owner at Splunk. So that's my quick intro, but I would like to invite everyone to give a little bit of a 2-minute intro about kind of the work that they do and their connection to the world of AI, and then we can get started with the panel. So. Yeah.
I think I'll skip. I just introduced myself. Sangeeta, why don't you go ahead? Yeah.
Okay. So hello, everyone. As Sridhar mentioned, I work for a company called IASTI, and we are a software company that works with large enterprises in a few different verticals, such as banking, healthcare, and the federal space. And what we're doing is we provide them a platform that allows them to quickly build up intelligent applications. And to situate what that really means, and I know we'll talk more about definition of AI, but just to quickly give you a sense of what it is we do, is if you look at the enterprise and all the big systems that are in place, the CRM systems, the ERPs, and a lot of the other systems that are very vertical focused, really not many of them, or I would say almost none of them, are equipped with any kind of intelligence. And so they are monolithic, and they will, over time, find it very hard to keep up with the changing needs of the enterprise business. So we are here to initially augment those systems, and I think very soon AI will be central to all of those systems.
Well, hi, everybody. I'm Lillian Rankin. I am Director of Product Management for the Google Assistant. I think on the pamphlet they said Google Home, but just so everybody knows, the Google Assistant is the software essentially that powers things like the Google Home, but also is available on your phone. And I think I'm on the panel, partially because obviously the Google Assistant is one of the hero products for Google that does leverage a lot of AI in several parts, such as speech recognition, contextual suggestions, and translation, other things like that. Prior to Google, I was at Skype, actually. There I led also our artificial intelligence product team, launched features such as Skype translation, which enabled you to do real-time closed captioning of video calls, which obviously use machine translation, as well as introduced our bot ecosystem into Skype. So this idea of conversational agents that, usually people come to Skype to talk to people, but actually this concept of people coming to Skype to be able to talk to bots like the Expedia bot or the eBay bot, and essentially have a consumer to business type of interactions. So yeah, happy to be here. Thanks.
Hello, everyone. This is Jonathan Cervelli. I work at Splunk as the head of product for our largest unit, which is IT Operational Analytics. And I believe I was invited to this panel because Splunk has been the biggest and probably most successful, at least economically, in the big data and machine learning space, with almost $1 billion in revenue. And what we do specifically is we take huge streams of unstructured, messy data, and we use machine learning and inference to build a schema for you, so we can extract charts and tables dynamically in real time for many different people in many different ways based on what their interests are. And we've helped thousands of very large enterprise customers primarily, names you probably know, do very interesting things with machine learning using our platform. And so I have a lot of customer stories and interesting anecdotes about how machine learning is actually being applied out in the real world.
Okay, great. Thanks for the intros. I think I wanted to start off by asking a very simple question to everyone on the panel, as in how do you define what artificial intelligence is based on your perspective, the work that you do, and how you apply it? And I'll start off with a very, very simple definition myself. And for me, in work I've done, AI really boils down to automated statistics. It's a very simple way of saying it, but that's how we view it inside the work that we're doing. But I'll start off with you, Rishi, and just look forward to what you think AI is and how you define it.
Yeah, definitely. I'll just reiterate for the benefit of the panel in case you didn't hear. So cognitive, I think, describes it well, at least from where I sit. And I actually really like that framework of understand, reason, learn, and interact. So a system that can understand and draw some concepts from that understanding, something that can reason about it. And we could debate what reasoning means, but at least assign probabilities to outcomes, is a way to look at reasoning mathematically. And then if it can learn consistently and sort of correct itself, as it gets feedback and interaction from some sort of end system, that makes a model for AI.
Great.
So the way we have defined AI when we are going to market is an enterprise application has to be exhibiting 5 different things to be called intelligent. And the first thing is it has to be able to discover what lies in the relationships within the data for itself. So we provide a version of unsupervised. You could also do supervised to understand what is the data telling you. And so that's the element of discovery. So it has to be able to discover. And then since you now understand what lies in the relationships in the data, you're able to predict. What we think is very critical is that prediction cannot be a black box, and I think you talked about this as well, especially in the enterprise world where regulators are talking to banks and banks are getting fined in the order of billions of dollars because they are not able to explain and justify the actions that they're taking. So it's very important that the intelligent application also justifies. And then it used to be that there was the world of AI was limited to producing very thick PDF reports and models and charts, but that's no longer sufficient. The system also has to be able to act. And then finally, as Rishi was saying, you have to keep learning over time, otherwise it becomes stupid, basically. So those 5 things is sort of our definition of intelligent.
Cool. So since I come from the Google Assistant, I thought I would show you what the Google Assistant has to say. What is artificial intelligence?
Artificial intelligence is the theory and development of computer systems able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages.
Yeah, so I thought hopefully you guys heard that. It's Google's definition of artificial intelligence.
We'll take that.
And yeah.
Well, who am I to argue with a machine? I would think actually my answer would be fairly similar to Sangeeta's, which would be that a artificial intelligence would be able to take a task and decompose what data it needs from that task, get the context it needs to turn that data into information, and ultimately make a decision path to execute that task. That's usually what we think about. I would just like to add one thing, which is that what AI is not, at least in my opinion, AI is not required to be self-aware, which is, I think, a very common misperception propagated by excellent but sometimes misleading science fiction.
Fantastic. So that's actually a pretty good segue. I had a couple of questions, but I'm going to be jumping around because I think that's a fantastic segue. That looking at what AI isn't, and a lot of the fears that are propagated by the media are all about AI taking over jobs, taking over the universe, and all the Terminator, Skynet kind of things happening. So one of the questions I have for the panel is, what is the hype today versus what is the reality? Because you guys are all on the front lines on the ground floor, kind of building AI systems. So I'd love to get your perspective on the hype versus the reality.
Yeah, I'll say that, I think there's a lot of hype around the negative aspects because it's what sells in the media, but really the reality is that the technology is very much in its infancy. And so at least, I can speak like on behalf of Google. I mean, we definitely are not looking at this as, technology that's going to do negative things. We're on the very opposite end of the spectrum, really thinking of really how does this technology, help consumers and the products that people use today. So for example, in like things like Google Photos, you can ask it like, show me pictures of my mom, and it's using machine learning to figure out, okay, who's your mom and how do you, bubble that up, and things like translation, obviously there's that. The Google Assistant, as I showed you, we do a lot of machine learning, to do better speech recognition to make the conversation as natural as possible. I think there are cases also where we're targeting very specific areas of research that I think the media doesn't talk about enough, but actually I think it's really noble, and it should actually be where most of us should put our energy into. And so things like, for example, partnering with pathologists to figure out like how do you use machine learning to detect breast cancer and really provide technology that is helpful to people rather than this rhetoric of like technology taking over people's jobs. I think generally speaking, if many of us can really focus our energy on focusing the technology is obviously very powerful, but if we focus the technology on solving these problems that can actually help assist people rather than replace people, we can move the conversation in the right direction.
Yeah, absolutely.
So, as with, I think, all hype and the other side of the coin being fear, it comes from a lack of really understanding what it is that it does. And so the challenge on the hype cycle is people's expectations are unrealistic about what AI can actually provide to them yet. And on the fear side, it's because of the lack of understanding. I find that there's general fear, such as the article about Facebook creating or a couple bots creating their own language, which was really far from what had happened. But it led to a lot of clicks, and it was an interesting water cooler discussion. And then there's personal fear, as in when we are working with these enterprises and we're trying to understand how we can bring intelligence into their world, there's a real fear from people that might worry, does this come and replace me at some point? And so that's, again, tied to, I think, the lack of understanding of what can be done. So I think it's up to all of us to really try and get to the bottom of it and understand what AI is a little bit better.
Yeah, I'll echo the sort of assist or augment message. That certainly our mission is to build systems that can augment what people do. On the hype side, there's this thing called the Turing Test. How many in the audience, raise hands if you know what that is? So a few of you do. So the idea here is if you can put someone in front of a machine and they think that there's a human being on the other side, that's one of the benchmarks that people have used to sort of classify something as an AI system. And in personal opinion, okay, this is not reflective of any place I've worked at in the past. My opinion here is that is a bit misleading. I don't think you're tricking someone into believing that there's a human being. I think that goal in itself is like a flawed one. At least for AI. Where I see a huge benefit is, as I was pointing out in that sort of cancer paper study as well. Systems can ingest way more data than human beings can. It's actually that data and the pattern, and I'm sure Splunk has access to vast amounts of data as well. It's that data and ingesting it and drawing inferences from it, in a way that a human being can't do. That's really where these machine learning, AI systems, I think excel. So I'll pause that comment there and see if.
Yeah, no, I think that's right. And there's a lot of, I think the fear does come back down to, will AI harm me or will AI take my job? Or make me in some way irrelevant or redundant? And we've had that fear since the water wheel, since we made the cotton gin. Those made people more productive. And that meant you needed fewer people. And that's the reality of any technology that's enabling and empowering. It's going to do that. And it might do it in asymmetric ways. And they might be both beneficial and have social consequences. A very tangible and similarly benign case in point. We work with a large cable provider that can mine data from all the different types of set-top boxes, dozens of different types of set-top boxes, from potentially dozens of vendors each. And they can figure out the combinatorics that will cause that box to be likely to fail and predict very accurately when it will fail. And so rather than have a truck roll, they mail you a new box and have you install it yourself. Do you like that experience? Probably. It's probably a heck of a lot better than losing your cable for 3 days. But that means they have fewer technicians and fewer trucks that roll, and there's fewer people who are being paid. So who wins and who loses? The question becomes really, as a society, then what do we do about that? And those are questions that usually, unfortunately, lag far behind the actual technology innovation itself.
Great. Lillian, you mentioned an interesting point about facial recognition in what you mentioned. And it brought up a conversation that we'd had with you, Jonathan, about how facial recognition was being used in different parts of the world, kind of without our knowledge, but for good. And in particular, it was about spotting terrorists in crowds in London. So I'm wondering if you guys could comment a little bit about that, because I thought it was a fascinating insight that we're being subjected to the effects of AI for good and for bad, but a lot of this we can't really talk about or isn't talked about. So I thought that was an interesting story. Maybe you could talk a little bit more about that.
Yeah, I mean, I think it's always like half glass full or empty. Like the half empty way of looking at it is like there's technology that you're not aware of that is doing negative things. I think we normally tend to look at it as like, hey, AI is actually the magic behind products that people don't know, and so it enables things like this Google Photos thing I mentioned. But you're absolutely, right that I think for me the biggest danger actually in where we are with the technology is making sure that not just a few people understand this, but that actually right now we do a lot across all the companies to make AI more accessible for more people so that there is more awareness of like what is happening, because to me that's really the danger. The other thing too, I think Google's also doing some work around how do we better understand how we measure and how these machine learning systems actually work so that you can bring awareness to some of these algorithms, because frankly, I think that, I was trying to explain this to my husband who's not in tech last night, but there is like this very big danger, that very, very few people understand artificial intelligence. And I think if we don't do a better job of making the technology more accessible to more and more people, you do have this threat that there could be these things that happen in algorithms that you're not aware of. And so, for example, at Google, we have open source TensorFlow, which some people may know about. It's a machine learning library. I think it's like #1 on GitHub, and it's helping to raise awareness. But I think generally as an industry, we need to do more to help people that are in tech, people that are not in tech, better understand, what it is that it is.
Yeah. If I might add, so I think one of the challenges with AI is not even all the practitioners of AI actually understand, why a given model behaves in a particular way. It is an open problem, very difficult to explain, even after you built the system yourself, why exactly it did what it did. I think that's one really difficult challenge to solve for. And I think what makes it harder in examples that you pointed out, spot terrorists and whatnot, is human beings have bias. All of us sitting here on the stage will have our own, individual bias. And if you are not smart about eliminating that bias from the data that goes into training a system, you could create something horrible, without doing it intentionally. It just may behave, horribly. So that's like the bad side, of I'd say AI and not understanding it, not spending the time to learn more about that side of AI. And by the way, this is like a research area. It's not like the solution is known and people just aren't implementing it. It's not a solved problem yet. The flip side of it also actually is interesting. Sometimes if you do have a large number of these techniques available in an open source sort of community, then people can make interesting use of them. I actually came across a really interesting article, I think it was like a few months ago. Someone looked at, you can find out flight pattern data for all flights in the US on a site. Data is just easily available there. Someone went there and tried to find out, if there were any spy planes operating in the US. And they actually claimed to have found a couple, and they pointed out, what their flight numbers and all that were. And I thought that's really interesting. I mean, here's data that's accessible to everyone, and suddenly you could tell, hey, wait a minute, this looks like someone's spying here, So I think there's a flip side, to AI as well. I think if you do make the data open as you can, and you do make the technologies available, I think it's, there's two sides to that coin.
Mm-hmm. Yeah, and I sort of add on that, as Vinod said yesterday, if you were at the gala, it's just a tool. It's simply a tool you put in people's hands, and they will use it to what they've been tasked or told or want to do. And if those tasks are good, then that is great. If they're not, that can be a little bit questionable. And who decides good becomes a really tricky problem. So, sort of to your point, I think there's a bias in technology. We people in technology think that we bias towards openness. We think information is meant to be free and things like that. A lot of people do not think that way. And a lot of people do things with AI that might not share that ethos at all. But they might not mean harm, even if you believe they might do it. So for example, we talked about facial recognition to spot terrorists. It's well known that various governments and places have made some notion or measure, or it's public record, they've sourced from companies like IBM, Splunk, Palantir, ability to go and do facial recognition in real time from cameras of people walking around. And why would they do that? Well, to spot terrorists or to look at people who are behaving suspiciously so that they can go intercept them. Places like airports. That makes a lot of sense, and that makes people safer. It, however, is not a big logical leap to imagine that same technology could just as easily be used against, say, democratic protesters like Occupy Wall Street or Antifa or things like that, or anything that particular person who had access to the camera, the technology, and somebody with the ability to intercept them might want to do. And we don't necessarily get to see, to your point about, Rishi, about bias, we don't see the bias of the operator, we don't see the bias of the people that wrote the software, and we don't see the bias of the overarching systems that are providing the data upon which the AI depends to make decisions. And those are going to be, I think, when we do finally find big, major ways that we find the outcomes of AI to be unpleasant, I think that we might very well find that it is a combination of combining, compiling, not necessarily errors, but subtle biases that become magnified until they become something we don't like. That would be my suspicion.
Yeah, that's actually another good segue, because the concept of bias is one that's very interesting, because a lot of the way an AI system works is really heavily based on the training data that you use to educate it. So the question pops up, are there inherent biases? And certainly I think a couple of days ago, there was something floating around on my Facebook feed about facial recognition being used to determine someone's sexual orientation, which I guess technically is, I guess, a pretty good achievement, but ethically that raises a whole host of questions. And so if we look at the biases that go into how an AI is trained, there's going to be racial biases, there's going to be gender biases. I think that's something that we talked about when we were preparing for this, and I'd love to kind of resurrect that, because I think that's very, very important in this day, because it can be used very badly, and like you say, you never know what went into the training set. And so, esteemed panel here, can you tell us how to mitigate some of those risks?
Okay. I'll jump in on one of the things that I was worried about, which is, to your point, it is about taking the data and then training on it and learning from it. But there is inherent bias in societies. If you know that there's bias in the way police are arresting people and the things that they're looking at, and if you just blindly look at that data set, we are going to just perpetuate that bias, right? Because that's the kind of person we would consider a criminal just because the data is saying that. So this is a part of the inherent responsibility of the person who is looking at AI and trying to develop the application, to understand where bias is already existing in the data and how to take that out. But then there are ways where I can say we had an opportunity to work with Splunk at Docomo in Japan, and we just looked at network traffic and looked at it from, without defining what fraud is, just looked at what looked different, and then tried to understand why is it different, and we were able to actually find malicious actors in the network. So there's a way to use AI in the right way, but to your point, we could end up inadvertently perpetuating and accentuating the bias.
Well, and I'll give a funny personal story, because this only connected the dots for me recently. So you can see I'm obviously Indian, brown skinned guy. I used to go to the airport very frequently, use the washroom there, and I always had trouble kind of hitting the soap dispenser, in this one particular airport. And I just thought, maybe I'm just doing something wrong. And guys around me could use it. I was like, I'm probably just doing something wrong. Didn't think about it much. Till I saw an article about, this actually was a problem, because they didn't use test subjects for that particular sensor with enough difference in the tone of their skin, so it would pick up the fact that, there's like a hand here that's moving. And for me, it's like a personal funny story. This happens to be a situation where it wasn't like a catastrophic thing, but you can imagine if you don't take care of of these kind of biases in your input data for a sophisticated system, and you start using it in criminal justice, for example, I mean that affects people's lives, in a major way. So I think depending on what kind of system you're designing and who the end target audience is intended to be, I think the responsibility is certainly on the community to make sure that we educate people in this space about all the practitioners about handling this issue upfront and understanding what biases might exist in their in their data sets and how this could be amplified massively as our systems reach production scale.
I was going to say, sort of in addition to that, the two things. One is that bias is also on the side of the interpreter, not just the side of the machine. So you can put bias in and get bias out and not know it. To that point about the hand soap dispenser, you also can find bias or believe you find bias where it doesn't necessarily exist. So if I want to, I think of that as a numerology problem. If it's in the movie Pi, if I tell you, look, that the number 238 is magical, you will find 238 everywhere. And so if I want to find bias in a machine, I can go and I can make up an algorithm, or I can tweak an algorithm that will make it tell me something I wanted to see, whether it's bias or not bias. And that's an interpretation, so it's also a little bit challenging. There's a bias that is inside the data and the bias that is inside of the interpreter, aka you or the operator. And both are insidious and both are problematic and very hard to remove.
Yeah, and actually following up for that, I think it's important, like ethically, to make sure that machine learning is inclusive, and that it goes back to making sure that we try to open it up and let people of all colors, of all genders, have access to it, understand it, so that we don't have bias in people managing the systems.
Yep. No, what's interesting about the whole concept of the training set is the same AI system can perform very differently based on what you've trained it on. And this brings back something that I had experienced a few years ago when I was in the medical device space, where we were considering using AI-based algorithms to do particular types of medical detection. And one of the challenges we ended up with was if we submitted something to the FDA into a regulated environment, and much like what you said, Rishi, I think you hit the nail on the head, which is we don't really know why it works. And so if you can't explain that, and the system learns and gets better over time, that's kind of incompatible with a regulated product for something you submit to the FDA. So I'd be kind of curious to look at your perspectives on the how we can disseminate and have a very pervasive set of AI products and tools, when ultimately underneath we may not know exactly why it works or how it works, or even know the biases that went into the training set. And especially I know Singhi, that you also work in the healthcare space. I'd be interested to hear how you deal with something like that.
So one of the applications we have in the healthcare space is we help hospitals understand the variation in care. And it's, if you walk into a hospital for any kind of a procedure, I'll pick an example at random, say a knee replacement surgery, you're really at the mercy of what the physician themselves decides to do in terms of a care treatment path. And they're influenced by their peers, by their journal, whatever their literature they've been reading. But if you look at the data and you look at what the variation exists in the data, you could actually see which are the groups of people that have recovered the soonest, and then sort of do a time series analysis to see what was done to them and say, could this be a sort of a recommended care path? Now, we are not dictating to the physician what they need to do, but we're saying here's something that you should look at, and physicians are asking for that justification. Why did you pick this group? And what about all these comorbidities? What if the person has diabetes? So we are really working hard in providing that justification. So at least in our software, we're able to explain what the characteristics are that define those groups. Similar to the banking industry, we have to do that. In any industry where we're going in and we're not able to explain that, that has become not an industry we'll be going in at all. And I think fortunately for us, the kind of technology that we are using is allowing us to do that. But there's many forms of modeling that would not allow you to really explain what has happened and how the decision has been made.
Yeah, I think there's a lot to do with the level of impact, right? So there's a lot of things that, for example, I don't need to understand how Google et al. Have made very smart talking boxes. I don't need to know, because if I ask it a question, it gives me an answer, and that's great. I'm not necessarily asking it to make critical life decisions for me. It's just aiding in helping my day. A medical device probably is a little bit more serious, and I probably want to know a little bit more about how it works. I actually worry about something a little bit further down the road, which would be when people stop worrying, when the machines get good enough that they don't actually catch when the machine has made a false inference, is going down a dangerous path. And I think that if you look more and more, we will come with things like, self-driving cars. We already have self-flying airplanes, so what's so wrong with the self-driving car? But you think you have to have a lot of trust that when you turn the autopilot on an airplane, which now in theory can land and take off by itself, that it's going to do the right thing. And I think that there's a particular risk that as operators get less informed and the technology gets more complex, especially as it can perform multiple tasks in interrelated ways, that our QA and our sort of inherent questioning of things will just start to fall by the wayside. And that, I think, is sort of a dangerous precedent. I think we always have to, someone has to always watch the watcher.
Yeah, I'll just add one point there, which a different way of sort of approaching that problem. And certainly, we have to do these things on the sort of machine learning side, but we also have a pretty strong design practice at IBM, and it's an independent division. And then we have designers that we get from there that work on our individual sort of product areas. And the advantage of setting up a discipline like that, much like machine learning is a discipline, design is a discipline. I've started to see this, much more education on that design side, pushing for these kinds of things in products too, and I think that's a really healthy sign. So in order to develop trust with the end users, have designers always ask, okay, it's good that this thing worked, but are we building trust constantly with the user? And are we showing them the results in a way that they can understand why a decision was arrived at? So I think a combination of just practitioners in the field recognizing it's a problem, product designers being able to push it from that product design point of view will help the space evolve.
Okay, great. I've got one last question for the panel, and then we'll open it up for questions from the audience. A lot of what we've talked about today is what's generally known as narrow AI, or mainly training a system to be really good at a particular task, like facial recognition or speech recognition, or something like this. What do you guys think we need to do to move from what's really today pervasive, which is narrow AI, to generalized AI, or artificial general intelligence, where a system actually starts to understand what's happening more and more broadly than specific tasks it's been trained on? So I would like to hear from you guys themes of what you're seeing out there and what you think we need to do from where we are today to get to artificial general intelligence.
I think I'll go first because my answer is pretty quick. We're not focused, I think, on general AI. We're very much focused on how do we provide value to users, and most of the AI that we do at Google is very specialized. So, the Google Assistant is exposing the ML that the Google Photos team is using. We're exposing the ML that the translation team is doing, or that the speech team is doing. But generally speaking, we don't have a goal of necessarily moving towards general AI.
Yeah, I would certainly not argue that general AI is a goal in and of itself. But how I think it may happen, I think we'll sort of stumble on it, will likely be the compounding nature of small iterative tasks that something can do. So if you take a machine today and it can do a certain task, and that it required traditionally human intelligence, it's learned how to do something, and that's great. Now you have a repeating robot that's doing a thing that's kind of clever over and over again. But eventually, if you teach that to do something else, and something else, and something else, the number of tasks that it can complete start to look a little bit more like an actual human. And I think that that's the way we're going to get to things that pass sort of, a multi-factor Turing test. Can it walk and chew bubble gum and recognize a face at the same time? And that's where I think you get to a human-like notion of, gee golly whiz, this thing starts to seem kind of smart. And it can do a lot of different things. And once it is able to combine tasks to do a third task that you didn't ask or knew it could do, I think you may have started to cross that line.
So I think my situation is similar to Lillian's, as in we are very focused on purpose-specific AI. Just personally speaking, general AI is interesting from just a thought, experiment. The other thing is, how do you make the AI have a will of its own? So you could teach it to win at Go, but does it really want to do that, or does it want to do something else? But personally speaking, none of our applications are anything but very specialized, and we are very focused on figuring out how does the machine augment the human being to get better value within the enterprise.
Yeah, again, we're definitely not focused on trying to build anything, any form of general AI. I think that there's like the, sort of science fiction fan part of me that's like, wow, wouldn't it be cool if, something like this evolved? But there's the practitioner of me, part of me, which deals with these technologies every day. And I think even conceptually, we're not at the point in the actual implementation, where I can see this thing, becoming smart, on its own in a way that you would really think something intelligent, would behave. I think within a given set of data, within a given set of confines, I think it'll find, optimal solutions, and that's how we focus it on industries and domains and, job roles and, image recognition, voice recognition, those kinds of things. So I think systems will get much smarter at understanding what we do and what we want to do, but only because they've been trained with that specific intent in mind. I don't think we're at anywhere reasonably close to a system automatically evolving on its own to solve a different problem than the one that its designer created with the way you see in science fiction movies. So I think that gap is huge. I think it's a wonderful research area, and if there's people that want to research it, I think it's fun. Because only when you really push the bounds of what we can do you do something different. So I'm not saying we shouldn't try to do it, but it sounds like none of us here on stage are really down with that pursuit. And at least based on where I see the technology today, it doesn't look that kind of AI does not look close.
Great, awesome. Well, we've got about 5 minutes to take some questions from the audience. I'll open it up to anyone out there.
Hi, my name is Elizabeth. So I have a quick question on more of a technical question. How do you, what kind of technology you use to predict the intention? Let's see, LSTM is one of the algorithms that you know. Usually people say you use the LSTM, long short-term memory, to predict the intention. Let's see, in a self-driving cars use case, what would be the biker's intention? And in the conversation, in-text conversation, online sales user, and also the assistant kind of a user scenario, that what would the user going to do after they perform a certain kind of a task and in certain kind of a environment, what would be their next move? I'd like to ask the panel to talk about the technology, and do you think we are very close to predict the intention or not?
So I'll say for the Google Assistant, like I mentioned, I think there are some very specialized areas that we're looking at machine learning, like speech recognition, language understanding, obviously. With respects to prediction, you could try it yourself today on the product. We try to use models to predict what is the next likely thing you would want to do with your assistant. So we have these things called suggestion chips, for example, on the phone. On the Google Home device, you would sometimes hear things like, after you ask for something, it'll say, by the way, I can do X, Y, or Z. And this is a form of predicting what we think the user might do. So as an example, parents and kids like to interact with our technology, and they like to ask things like, okay, Google, what does a whale sound like? And so it'll tell you like, oh, the whale sounds like blah. And so we know that they're playing, right? And so we will suggest other sort of playful things like, oh, would you like to hear a joke, or would you like to play a game? Because they're kind of contextually related. So that's how we use some of the prediction.
Just a very silly joke. You actually say, would you like to play a game? That would be a little bit scary.
Maybe to, I think there's many parts to your question. So first, systems like this have several components. I don't think I could name like one technology that works across, between, speech to intent to predicting. There's a variety. It's like a large pipeline, and pieces of that pipeline, keep changing and evolving as well. So I don't think there's one technology I could say that's like, hey, that's the one, it's going to work for a task like this. The general observation that I've seen at least in conversational applications is if you know the context you're operating in, there are definitely patterns. And we absolutely, try to understand what those patterns are, and then based on those patterns, make suggestions. Trying to do it in general conversation is hard.
Yes.
But if you contextualize it and you're talking about
right, if in a assistant, in a Google Assistant user scenario, you know this person pretty well. But when you're AV, you're driving on the street, the bikers, you don't really know much about the bikers, and you cannot really predict what's their next move. They could turn left, they could turn right. So I think that's kind of hard. Or you're kind of a general salesperson try to sell particular product. Let's see, a bottle of wine to a general public, you don't even know who your customer is going to be. And that's where I think the real challenge coming from.
I do know how some of our customers have handled similar challenges like that with predictive modeling. So usually what you're the challenges you have are how deep and how wide. In other words, how many compounding choices must I decide before I get to my endpoint, as well as how wide are the possible outcomes at each decision step. So in the case you're talking about, or the Google Assistant, that is a very, very wide and fairly shallow step. I have to predict the next move. That's it. From the current context, that's great, but hugely wide. There's an unlimited number of things it could predict. Mm-hmm. You use certain types of modeling for that gets, which we won't have to get into for the rest of the audience. The ones that tend to be very deep, what you generally tend to do is you tend to build out probability trees, where you say the probability of people going to this step is this, and then at each step you use independent categorical inference, which is a technique people use based on a constrained number of variables, which are the most predictive in what that person or that case is going to happen next. And you just iterate through those over and over again, and eventually you may have to learn at each different step. You use a different set of data and a different categorical inference model, but most of the time for things that are very long, a pathway very long like that, that's what people tend to use. So modeling, for example, the drop-off rate of somebody trying to move through a checkout process of finding a product, checking out, what will they do and what errors are they likely to find and how they're going to fall off, is like an area where you'd use that kind of multi-step categorical inference as an example.
Yeah, thank you. That's really great to get your suggestions, and a great panel. Really enjoying it. Thank you.
Thank you.
Right. You have time for one more? I'm interested in the topic of information warfare, and I know that Google and other companies are using artificial intelligence to address fake news, disinformation, fake accounts, et cetera, and would like to learn more about that from the panel and what they think are new approaches that need to be taken to address manipulation of political systems around the world.
Sorry, I didn't hear that. Manipulation of what kind of systems?
Yeah.
I'm sorry.
Yeah, manipulation of political systems.
Political systems around the world, how they're being manipulated by this type of information operations.
Well, I don't think we would not know much, and if we did, we couldn't tell. But I would say that in general, if we look at similar kinds of systems that are used for, let's just say, managing or maintaining very complicated software-defined networks and defending them, the techniques you would generally think about people using would be very, very complicated sets of multi-causal scripts. So I think it starts out, if we look at the history of increasing automation in both offense and defense in large-scale networks. You first do if-then scripting, and you say, okay, if I see this, then do that, sort of a basic reactive measure. And then what you can do is you could begin to build these decision trees that say, okay, this is what a particular type of advanced persistent threat looks like. This is how the attack vector goes. Here's the kill chain. I'm going to stop the kill chain here. And this kill chain has this many forks, and you can actually map them all out. And then you can, quote unquote, train the computer. Now, at that juncture, that's not all that interesting. It's just very sophisticated scripting. And I think that's probably where a lot of people are at right now. And where they tend to be challenged is when you get a new persistent threat that fails to match the pattern. And how do you reply to it? What that means, that if you think about how antivirus developed, you see a lot of fuzzing techniques out there where people will put in deliberate randomness in terms of the attack chain. They will put in multiple vectors at a single point in the kill chain so that you don't know which way they're going to go, sort of more moves on the chessboard. And there's constantly an escalation game that happens with people doing that. It would not surprise me, although I have no specific information, that people have used decision AI trees that are much more sophisticated. Think about what you might use for chess to try to navigate and do sophisticated attacks of networks. That would not surprise me at all, but I have no, I bet you it's being developed and not telling anybody about it.
Yeah, I was going to say, there's definitely work that IBM does with a variety of branches of the government that, we certainly can't discuss. But one interesting space in machine learning, which I think will help, is it's called adversarial networks. So, you sort of have a given way that you solve one problem, and then you build another machine learning system to try to break it down. That's effectively you're simulating an attack, on your own system. And I've seen some really interesting, again, these are research topics, not necessarily topics where, there's product already out there that you can use. But that's a good way to, understand how your system behaves, when an unknown kind of attack, comes at it, and sort of strengthen it. So that's one of the areas I've seen evolve in the space.
So I guess I'm in a similar boat where I can't share specifics with what we're doing with some of the government entities, but I can say that in general, we have used in some of our engagements a very simple approach that has been surprisingly effective. And these are the detection of low and slow threats on your system. These are people that are lurking in your network and potentially up to no good. And we use the concept of similarity analysis. So we look at the transactions that these users are doing in the system. And their behavior, if you look at that sort of similarity analysis, they tend to look very, very different than the normal behavior. And that tends to make it quicker compared to many other ways to detect sort of these low and slow threats. So I can talk about that a little bit, but there are many more complex engagements where we've been using this that I'm not quite able to share.
Thank you very much.
Okay, great. I think we may have time for one more question, and then...
Hello, thank you for the people on the panel for being ethically responsible and highlighting how to use specific AI rather than general AI. However, there are people out there who are interested in building a general AI. As experts in the AI community, do you guys feel that you have the responsibility to be public proponents against general AI? And do you think that signing something like the Asilomar AI principles is enough, or should there be more government regulation?
One thing I will say about a general challenge of government regulation and technology is there is no world government. Maybe you feel good about that or not, but it's the truth. And so we can say we will not do this. I generally feel that human beings reach for technology like it's damn near instinctive, no matter how wise it potentially is. But I do think that it is an ultimate reality that general AI is merely a technology tool. And it's a question of what task you put it to and what you have built it to do. And if you put it in charge of a nuclear arsenal, I'm absolutely terrified. If you put it in my phone and make it give me intelligent answers, I am probably going to like it quite a bit. It's really just a question of making sure that you think about what the right thing to do is. I generally share your concern, however, that technologists very often build first and put in safeguards or ask ethical questions later. And we as an industry have to get better at doing that hard thinking first. We tend to try to solve the problem, and then the problem creates a new problem, and that's not been the best way to operate. And I hope we learn to do better in the future.
Yeah, I'll pre-qualify my statement by saying this is not an official position of my company. It's my opinion. I think the pursuit of understanding what intelligence is an important one. I wouldn't want to suggest that we shouldn't try to do that kind of research, because I think it's just we're intelligent beings, and we want to understand what makes us intelligent. So that's like super important. I think I think where systems are today and, whether we'll be able to build something soon, I think that I've said is really far away. I think the interesting way to sort of, to build some responsibility here, instead of just outright regulation, is to do it in an open manner. With security, for example, SSL and those kind of protocols, they were always developed, open source. People could look at the code, understand vulnerabilities, suggest fixes to them. And I think if we adopt that kind of an approach for general AI, where people researching, in the field, are open about what they do and share their work, I think it'll be easier to build in, the kind of safeguards necessary over time. But I would project it's a long span of time, not occurring in a hurry.
Okay, I think we are good on time. So thank you all for coming to our panel, and please help me thank the panelists for their time.